Hello students, our next topic is Kirchhoff rules. Kirchhoff rules or Kirchhoff laws. Okay, so these Kirchhoff rules are related to solve the complicated circuits. Okay, by solving the complicated circuit means to find the voltage, to find the current and to find the equivalent resistance across the circuit, across the more complicated circuits. Okay, we can also find this by using the Ohm's law, but Ohm's law has its own limitation. We cannot solve the complicated circuits by Ohm's law, especially when more than one or more than two batteries are given. So by using Kirchhoff rules or Kirchhoff law, we can solve the circuits very easily. Okay, so Kirchhoff gives the two laws. First law is known as the junction law. First law is known as the junction law. Junction law, or it is also known as the current law. This is also known as the current law. Okay. Now, what is this? The current. What this law says that the current entering the junction is equal to the current is equal to the current leaving the junction. Okay. So this law tells us that the current entering the junction, okay. Now the current entering the junction is equal to the current leaving the junction. Now what is the junction? Junction means the point where the three or more wires are joined. Junction means the point where the three or more wires are joined together. So this is known as the junction. Now suppose if you have this is a point junction. Now here the current I1 is coming, here the I2 is coming, and you have three paths where the current will leave. इस पॉइंट पे I1 I2 आएंगे और इस पॉइंट से I3 I4 and I5 are the leaving. I1 and I2 entering the junction, I3 I4 I5 leaving the junction. Then according to this law, I1 plus I2 is equal to I3 plus I4 plus I5. Okay. यहाँ पे जो करंट जितना करंट आएगा, दिस इज I1. Okay, so I1 and I2 the entering the current, and I3 I4 and I5 is leaving the current. Okay, so this is known as the junction law, or we can say that the sum of the current at the junction is 0. The sum of the current at the junction is 0. Okay, this we can prove that. This we can say, here we can write I1 plus I2 minus I3 minus I4 minus I5 is equal to 0. If we consider the current entering as positive and current leaving as negative, then the sum of the current at the junction will be equal to 0. Okay, so this is known as the junction law. This law is based on the law of conservation of charges. Law of conservation of charges. This law is based on the law of conservation of charges. Means jitne charge, what current means what? Charge, number of charge. So the number of charge that will come to the junction, that same equal to number of charges will leave the junction. There is no loss of charges at the junction. Okay, so this is based on the law of conservation of charges. So this is known as the first law. Now we will study the second law. Okay, now second law is known as the loop law, or it is also called as the voltage law. It is also called as the voltage law. Okay, now what this law says that, what this loop law says that the sum of charges, the algebraic sum of charges sum of changes in potential around any closed loop involves resistor and cells involving resistors and cells in the loop is zero. Okay, so this law says that the algebraic sum of the changes in the potential around any closed loop involving resistor and cell in the loop is zero. Okay, what does it mean? It means that if you have a loop, which consists of cells and resistors, so the sum of potential in the loop will be zero. Okay, जो पोटेंशियल का या वोल्टेज का जो सम होगा किसी लूप में वो क्या होगा, that will be equal to zero. Okay, so for that let us take an example. Here you have one resistor, one battery, here you have one more resistor, and here you have one battery. Okay, here you have one battery. Okay, so this is EMF E1, this is E2, this is R1, this is R2, the resistance. Okay, now E1, suppose the current I1 is going, from E2 the current I2 is going, so this is the point, this is the junction. Now here the current I1 plus I2 will go, यहाँ से I1 करंट जाएगा, यहाँ से I2 करंट जाएगा, तो इस जंक्शन पे जो करंट जाएगा यहाँ से ये कहलाएगा जंक्शन. दिस इज कॉल्ड एज द जंक्शन. ओके, so this I1 plus I2 and the current will go from R1 I1 plus I2, and this here again I1 plus I2 will come, then I1 will go here and I2 will go here. Okay, now what it says that if you take the sum of the potential, now you can start from anywhere, you can start from here also. Okay, so here it will be, if you go from here, then the current will be R1. What will be the potential? Potential is the multiplication of current and resistor. Then what will be the potential? Then this potential will be R1 I1 plus I2, and then here if you will go like this, then it will be plus E1 plus, then if you go there, then R2, the current is I2 plus E2 is equal to 0. Now here I have not taken the sign convention. We have to take the positive and negative, that we will take later. It is just for understanding. Okay, so यहाँ पे जो total potential था इस loop में, यहाँ पे एक loop ये है और एक loop ये है. This is the one loop and this is the another loop. So in this loop the potential, यहाँ पे potential होगा R1 I1 plus I2, यहाँ पे potential है E1, यहाँ पे potential है R1 I2 और यहाँ potential है E2. इन सब का जो sum होगा that will be equal to 0, and that we can write that V is equal to 0. The sum of potential around the loop will be equal to 0. Okay, now this law is based on law of conservation of energy. Law of conservation of energy. Okay, there is a, we know the first law is based on the law of conservation of charges. The second law is based on the law of conservation of energy. Potential is what? Energy per charge, that we have studied. So it is based on the law of conservation of energy, that there is no energy loss during the motion of the current around the loop. Okay, so these are the two laws. First law is the current law, second law is known as the voltage law. Okay, now in the next slides we will take some questions based on the Kirchhoff rule. Okay, thank you.